Welcome to a refresher course in Stormwater Pollution Prevention. This module specifically covers erosion and sedimentation control, also known as E&SC, and is intended to be a brief refresher course to help staff and contractors review the E&SC concepts. The concepts and messages included in this training apply to any municipal separate storm sewer system permit, also known as an MS4 permit. All MS4 permits are regulated under the National Pollutant Discharge Elimination System, or NPDES, regulations. This training was created by Orange County, who shares the responsibility for protecting surface water from polluted stormwater with several co-permittees, including the Cities of Apopka, Belle Isle, Maitland, Winter Garden, Ocoee, Winter Park, Edgewood, the Town of Eatonville, the Valencia Water Control District, and Florida's Department of Transportation. Within Orange County, there are at least 3 MS4 permits, and all are required to provide training. If you are taking this training, you need to know how to prevent pollution that can enter lakes, rivers, and ponds through stormwater systems. This is so your organization can be compliant with NPDES regulations that apply to MS4 permit holders. This training is for municipal employees and contractors working for municipalities. Both employees and contractors are expected to be alert for erosion and sedimentation control issues. This might include clouds of dust, turbidity in water, clogged stormwater conveyances, or any generally suspicious flows that could be encountered during routine work activities, particularly in areas with high-risk facilities. The state of Florida directs organizations that hold an NPDES permit to provide training annually, and it must educate about types of facilities that are subject to multi-sector generic permit requirements, or MSGP requirements, and any activities that could cause pollution. This training will cover the following topics: the basic elements of NPDES, what erosion is, what sedimentation is, why controlling erosion and sedimentation is important, which facilities are inspected for erosion and sedimentation controls, how to identify potential issues, and finally, what best management practices are useful for controlling soils on construction sites. When NPDES was created as part of the Clean Water Act, the main goals were to protect water quality, minimize pollution, and educate citizens and businesses about how everyday activities can pollute our waterways. Probably the most useful tool to come out of the NPDES legislation is the establishment of best management practices, which provide guidelines for preventing pollution before it becomes a problem. The NPDES program basics include regulating the discharge of stormwater to surface waters, restoring and maintaining the health of surface waters, and establishing goals and practices to meet pollution reduction targets from permitted facilities. This slide shows the timeline of how our NPDES program of today developed out of the Federal Water Pollution Control Act of 1972 and the Clean Water Act of 1977. The U.S. Environmental Protection Agency, or EPA, administers the NPDES program, but in 2000 granted authority to the Florida Department of Environmental Protection, FDEP, to administer 3 types of permits: construction general permits that apply to construction sites of 1 acre in size or greater, MS4 permits like the one that Orange County is regulated by, and industrial multi-sector generic permits that govern stormwater discharges from entities such as salvage yards and fertilizer manufacturers. Construction activities that disturb 1 or more acres of land and discharge stormwater to surface waters of the state or into an MS4 need a permit pursuant to the NPDES regulations. If a project is less than 1 acre, but part of a larger common plan of development or sale that will ultimately disturb 1 or more acres, a permit is also required for that. The major construction general permit, or CGP requirements, include the following: develop and implement a stormwater pollution prevention plan, also called a SWIP, post a notice of intent, also known as an NOI, undergo inspections, retain records, and submit a notice of termination, or NOT, at the end of the project. This slide shows some of the major permit requirements as broken down into general categories as listed on the slide. There are 14 major categories of compliance activities that are outlined in an MS4 permit. The first one being maintenance. This includes inspection, maintenance, and inventory of the MS4. That includes all the canals, ditches, ponds, pipes, outfalls, etc. It includes roadway maintenance, litter control, and street sweeping. It also involves incorporating stormwater treatment into flood control projects, limiting sanitary discharges, and making sure that stormwater treatment is required for development projects. Another component is inspections. Inspection of municipal waste treatment and storage facilities that are not already covered by their own NPDES permit. Proactive and reactive illicit discharge inspection programs. An industrial and high-risk runoff inspection program. And a construction site runoff inspection program. Monitoring is required. This involves auditing records and protocols to ensure that compliance is being supported. Training and education component covers both public and county staff. The public outreach and education component involves proper pesticide and fertilizer use, illicit discharges and public reporting, proper management and disposal of oils, toxics, and household hazardous waste. Training of county staff involves illicit discharge detection and elimination, spill prevention and response, and construction site erosion and sediment control training. Annual reporting to FDEP, or the Florida Department of Environmental Protection, involves accounting of all activities during the permit year, the status of your monitoring program, and the assessment of your program's effectiveness. Commercial and industrial pollution sources that can potentially threaten county water sources require a multi-sector generic permit, or MSGP. A few examples that require an MSGP include auto salvage yards, scrap recyclers, and construction sites. MSGP compliance requires the following information: the type of facility, the type of activity, internal auditing protocols, pollution prevention best management practices in place, and an education program for staff and contractors. Within the Orange County MS4, there are approximately 275 active construction sites and 6,200 stormwater ponds that have been located and inspected. The county is required to visit all industrial facilities and high-risk facilities. These include facilities listed on the Federal Toxics Release Inventory List, or TRI, any operating municipal landfills, and all hazardous waste treatment, storage, disposal, and recycling facilities. The county is also expected to look at any other deemed likely sources of pollution. These might include concrete facilities, stone cutters, auto recyclers, or chemical manufacturers. Many of these facilities, as we've talked about before, will require an MSGP, or multi-sector generic permit. The type of MSGP is determined by the industry code. Additionally, the NPDES team helps respond and eliminate illicit connections into the MS4 that have been identified by the Public Works maintenance teams. Stormwater pond inspections and industrial inspections are part of the proactive illicit discharge inspection program that's required by the NPDES permit. This is one of the key compliance elements for Orange County. So what is erosion? Well, the definition of erosion is the process by which the land surface is worn away by the action of wind, water, and gravity. Soils that have a small particle size are prone to erosion. In Florida, clay and muck are the two soils that cause the most problems with turbidity and erosion. Whenever a project involves disturbing soils, design controls must be in place to limit erosion. Site conditions and soil types will dictate which controls are most successful in keeping soil on site and maintaining compliance. What is sedimentation? The definition of sedimentation is settling out of soil particles transported by water and wind. Sedimentation is basically what happens after soils have been displaced by either wind, water, or gravity and deposited in a new location. There are negative physical and biological impacts that can result from soil being deposited in undesirable places. The physical impacts can result in costly damage to aquatic areas and to private and public lands. For example, if a navigable river is obstructed by masses of deposited sediment, it hinders shipping and recreation, it requires costly dredging, and also increases the likelihood of flooding and flood damage. For a local government, when sediment fills stormwater conveyances and plugs culverts, frequent and costly maintenance is required. In the United States, millions of dollars each year are spent to purify drinking water from sources that have become victims of sediment runoff. The biological impacts are even more critical than the physical impacts, because sedimentation has the ability to upset an entire food chain of a water system. Fine-grained sediments such as clays, silts, and fine sands in an aquatic system reduce both the kinds and the amounts of organisms present. This happens because sediments are able to block out sunlight. That inhibits photosynthesis and decreases aquatic plant health. This sets off a chain reaction that affects life from the smallest organisms to the largest inhabitants of the affected water bodies. Consequences can involve food sources becoming scarce, fish not being able to spawn, and even gills of fish becoming so clogged that they suffocate. Coarser grained materials are also able to blanket bottom areas and suppress aquatic life in waterways. Preventing physical and biological impacts is a critical component of every construction project. Preventing pollution from uncontrolled sites involves many aspects, including the following: planning, training, equipment, best management practices, permits, inspections, maintenance, and coordination. Land development activities expose disturbed soils to rain and subject them to stormwater runoff. Site alterations often detrimentally affect stormwater patterns and eventually off-site stream and stream flow characteristics. When protective vegetation is reduced or removed, earth is excavated, topography is altered, the removed soil material is stockpiled, often without protective cover, and physical properties of the soil itself are changed. Even a small development project with uncontrolled erosion and sediment can cause considerable economic damage to affected property owners and society in general. Unless good planning and strong site stabilization program is implemented, soils can leave the site and become a big problem. This presentation will discuss how planning, training, well-maintained and inspected equipment, best management practices, coordination with all parties, and proper permits help ensure a successful project with limited environmental and economic burden. This slide is a little bit longer than the others, but it has some very useful information to convey about 7 main principles that help control erosion and sedimentation on a site. Effective erosion and sedimentation control programs are well planned before construction begins, developing the site without environmental degradation while decreasing costs is the goal of the 7 principles we will discuss here. Vegetation, structural controls, and good project management should be integrated into every site plan to the maximum extent possible. Number 1, plan the development to fit the particular topography, soils, drainage patterns, and natural vegetation of the site. In other words, let the natural characteristics of the site help determine where permanent features such as roadways, parking areas, and buildings should be installed. A few examples of using the site's features to plan a project include the following: locating large graded areas on the most level portion of the site can help reduce costs related to controlling runoff. Keeping steep vegetated slopes undisturbed is also a good practice for reducing erosion and runoff potential. Otherwise, practices such as benching, terracing, and constructing diversions will be needed. Avoiding areas that are subject to flooding or integrating those areas into the stormwater management system is a good idea to avoid creating flooding problems downstream. Number 2, minimize the extent of the area exposed at one time and the duration of exposure. When land disturbances are required and the natural vegetation is removed, keep the exposed area small and the length of exposure time short. A few ways to accomplish this include the following. Plan so that the development takes place in stages, and only the active areas are exposed. Keep all other areas well covered with either temporary or permanent vegetation or mulch. Complete your grading activities as quickly as possible and immediately cover the graded areas with permanent vegetation when finished. Try to time your projects so that grading of large or critical areas doesn't take place during the rainy season. Number 3, apply perimeter control measures to protect the disturbed area from off-site runoff and to prevent sedimentation damage to areas below the development site. Just like equipment and tools are managed in a manner to keep them on a job site, sediment needs to stay there too. Plans should detail how erosion of soils from the site is stopped. Measures can be deployed to capture sediment before it leaves the site, including diversions, berms, sediment traps, vegetative filters, and sediment basins. Number 4, apply erosion control measures to prevent excessive on-site damage. Keep soil covered as much as possible with temporary or permanent vegetation or with various mulch materials. Use special grading methods where applicable, such as roughening a slope on the contour or tracking with a cleated bulldozer. Number 5, keep runoff velocities low and retain runoff on the site. When existing vegetative cover is removed, more impermeable surface area is exposed, and this allows more water to run off the site more quickly. Controlling this runoff reduces erosion and keeps your soils on site. Here are a few suggestions for controlling runoff. Keep slope lengths short, gradients low, and preserve natural vegetative cover. Safely convey runoff from the development site to a stable outlet using storm drains, diversions, stable waterways, or similar measures. Use stormwater detention structures if possible to prevent flooding and help control runoff. Any conveyance system should be designed to withstand the velocities of projected peak discharges. These facilities should be operational as soon as possible after the start of construction. 6. Stabilize disturbed areas immediately after the final grade is attained. Permanent structures, temporary or permanent vegetation and mulch, or a combination of these measures, should be employed as quickly as possible after the land is disturbed. Stabilize roadways, parking areas, and paved areas with gravel subbase whenever possible. Number 7. Implement a thorough maintenance and follow-up program. This last principle is vital to the success of the 6 other principles. A site can't be effectively controlled without a thorough, periodic inspection protocol of the erosion and sediment control practices. These practices must be maintained, just as construction equipment must be maintained, and materials need to be checked and inventoried. It's a good idea to start a routine end-of-the-day check to make sure that all control practices are working properly. The best erosion and sedimentation control programs start on paper, because good planning evolves into compliant job sites. Maintaining adequate perimeter controls is essential for keeping soils on site and preventing migration to the stormwater system. The image in this slide shows 3 important considerations for a site perimeter. First, the culvert must be protected to keep eroded sediments from clogging the pipe. Second, whenever wetlands, water bodies, or conservation areas are adjacent to a construction project, a double layer of silt fencing must be installed. And third, turbidity barriers require proper installation to make them effective. They do not work well in flowing water conditions, so alternative protections must be used. In this slide, we're considering the construction site plans for stormwater inlet drains and how the facility intends to prevent soil from being washed off the site and into the stormwater system during construction. When reviewing the inlet protection details, pay close attention to consistency on the plans. In this particular project, the note that was typed on the map refers to inlet protection with fabric under the grate, while the written plan states erosion control at all inlet drainage structures shall be done in accordance with FDOT Index number 102. The inspector's notes describe how the map notation is not consistent with the requirements of DOT Index 102. When reviewing site stabilization plans, make sure that they match up with the permit requirements under the CGP. Realizing that construction sites typically involve a lot of earth-moving activities, the regulations allow for temporary bare earth situations under specific conditions. The site plans, however, must reflect the requirements that are contained in the construction general permit. In this particular situation, the actual site plan said that they had 30 days before they had to cover the bare earth, but the permit itself said 7 days after inactivity. When reviewing site stabilization plans, make sure that the conditions actually meet up with the county ordinances. Here's an example of the Orange County Fertilizer Ordinance, Section 15, Article 17, and the site plan does not meet the same criteria as specified in the ordinance. Paperwork that should be maintained on site for inspection include the Stormwater Pollution Prevention Plan and the permit. These are required in Part 4 of the Construction General Permit. It's a living document, so it needs to be maintained. Key elements of it should be the site map, the inspections, whether corrective actions that are noted make sense for the site, if there's any issues identified that have been corrected per the permit, any contractor certifications that are required, and activities described in the SWIP that match activities on site. Key to keeping erosion and runoff under control. The next several slides will show examples of construction site BMPs. Some are good, some are bad, and some are just plain ugly. Tracking dirt from the exit are the two main complaints we get about construction sites. Exits should be stabilized. Rumble grates are good. Wash racks are good. They're needed for internal access points too, which are often overlooked. Common issues that we hear that are inadequate length of rumble grates. They need to be 50 feet wide. The stone is too small, should be 2 to 3 inches, which is best. No liner and no maintenance. So remember, when exits are properly stabilized, the equipment is fabric lined, they use clean 2 to 3 inch stone, and sweeping is done in conjunction with, not instead of, stabilized access, and rumble grates are many times used. Not be the only BMP on the site, but it should be done properly. Check perimeter BMPs for common controls such as silt fence, a staked turbidity barrier when needed, floating turbidity barriers where appropriate, double layer silt fencing at wetlands, water bodies, and conservation areas, vegetative buffer strips where needed. Some of the common issues that are seen with regard to perimeter BMPs are that they're not properly located, or it's the wrong BMP that was selected, or it's poorly maintained, or poorly installed. Regarding outfalls and stormwater ponds, check for erosion at the outfalls, turbidity, adequate BMPs being in place, adequate stabilization on the interior slopes, and the pH of the water. In these cases, turbidity is a main concern because turbidity always needs to be at levels less than 29 nephelometric turbidity units, or NTUs, above background, unless it's an outstanding Florida water where the level should be 0 NTU. Outstanding Florida waters in Orange County include the Econ River, the Ocoee River, Rock Springs, the Little Econ River, and the Butler chain of lakes. Inlet protection is a commonly seen best management practice. Typically, sock pipes are used, but they're not very effective. Many times they're poorly maintained and often removed by residents. They are the last line of defense before impacts to stormwater ponds and possible discharge. Controlling dust on a site is very important, and you must initiate stabilization measures within 7 calendar days after construction activities have either temporarily or permanently ceased for any portion of the site. Watering is good, but stabilization is best, using not just sod, but also plantings. Polymers are good for soil binders, but they have to be non-toxic, such as anionic polyacrylamides, or PAMs. Every site has construction materials that serve as potential pollution sources. Making sure that materials are managed in a way that prevents pollution must be a priority for any project. Items that could pose pollution risks include the following: washout of concrete and stucco mixing equipment, paint, construction debris and waste materials such as caulk, adhesives, and drywall mud, litter from packaging materials or construction crew waste, fuel storage tank leakage, equipment maintenance activities that involve oils or maybe cleaners, portalets that are improperly maintained or precariously positioned on the site, and even failures of hydraulic lines from equipment in service. To wrap up the best management practices area, keep in mind that construction sites many times employ best management practices that are either not adequate for the project or have not been maintained. Keeping a site in compliance takes coordination with workers, daily inspections, and constant maintenance. Make sure that BMPs always meet the requirements of the 2013 State of Florida Erosion and Sediment Control Designer and Reviewer Manual. Make sure that all BMPs are installed prior to demolition. Be mindful that most E&SC plans are typically not adequate for actual site conditions. Question the turbidity and muck handling practices, and make sure that BMPs at fill slopes are adequately addressed. This slide illustrates well how construction projects change over time. As the project proceeds, the BMPs need to evolve to fit the pollution prevention needs of the surrounding natural areas. Many sites require dewatering for the construction project. Unfortunately, most site plans and schedules do not plan well to manage dewatering properly, and this can cause costly project delays and even enforcement. Before beginning any dewatering operation, appropriate permits must be obtained, and a dewatering permit may be obtained in conjunction with the CGP. Always consider that there could be contamination issues with the groundwater being removed, and discharging that produced water could cause likely problems. Because there are many sites in Orange County that have groundwater contamination, all permits for dewatering require sampling and analysis prior to discharging to the ground. If the water is contaminated, it may be discharged to the sanitary sewer, but only after a permit is processed. If the water is determined to be non-contaminated, but the plan is for discharging to a right-of-way easement, a permit for that is required because it is a discharge to the MS4. A few common problems encountered during dewatering activities include turbidity and inadequate BMPs. Both of these are the result of lack of planning and will cause project delays or regulatory violations if not immediately addressed and corrected. This is another example where good planning and preparation before project kickoff saves money. Thank you very much for taking this training. Keeping pollution out of Florida's waters will take a vigilant, coordinated effort as our population continues to grow and stress our natural resources. But working together, we can make a difference in the health of our water bodies and leave a wonderful legacy for future generations of Floridians and visitors.